There's a stove you can build in under 30 minutes for less than $1 that will cook your food, boil your water, and keep you warm in an emergency, and it has been doing exactly that for thousands of years. Not almost as well as a $60 propane canister system, not comparable to it, measurably, provably better in terms of cost, portability, and self-sufficiency. It weighs less than 2 ounces, it fits in your palm, it runs on fuel you can buy at any hardware store for $7 a quart. A peer-reviewed study published in a Taylor and Francis journal documented this same thermal principle reducing home heating loads by between 50 and 80%. Archaeological sites in Xinjiang, China, dated to 7,200 years ago, show humans already using this exact heat capture system. The portable camping stove industry Coleman, Jetboil, Miser, Camp Chef, Primus, Solo Stove generates over $600 million a year selling you pressurized canisters you cannot refill at prices that climb every season. They did not forget this existed. That would be an accident. They buried it. That was not an accident. It was a decision. This is the story of the DIY alcohol can stove and what it does and why a $1 solution that ends canister dependency was never supposed to reach you. Welcome back to Science of Survival, where we open the vaults, hit subscribe and the bell if you are not already in. Around 5000 BC, in the Wei River Valley near what is now Xi'an in northern China, a settlement called Banpo was home to several hundred people living in semi-subterranean dwellings cut into the earth. The winters in that region were brutal. Wind came off the lowest plateau with nothing to stop it. The ground itself was the enemy. Archaeologists excavating the Banpo site found something that stopped them. Beneath the sleeping floors of these dwellings were carefully constructed layers of ash over fire basins, the remnants of a system designed not just to heat a room but to store heat inside the earth itself and release it slowly through the night. The people of Banpo were not warming air, they were warming mass. They understood something about thermodynamics that we teach in university physics today. A fire is inefficient when it heats the air around it. Air holds almost no heat. Stone, clay, and compacted earth hold enormous amounts. Build your fire beneath a mass, and the mass becomes the stove. It radiates warmth for hours after the flame dies. 700 years later, moving forward to the Zhou dynasty in northeastern China, roughly 722–481 BCE, craftsmen formalized this discovery into a system so effective it is documented in peer-reviewed science published in 2008 in ScienceDirect. The system was called the Kang. It was a raised clay and brick platform that occupied 1/3 to 1/2 of the main living room. A small stove sat adjacent to it, burning straw, dried corn husks, or pruned branches from the orchard. Smoke and heat from that stove traveled through internal flues beneath the Kang surface before rising out a chimney. The clay surface above absorbed that heat and held it. Families slept on the Kang in temperatures outside that dropped to -20 or 30 degrees Celsius. The surface remained warm through the night. The Kang cooked food, heated the home, dried clothing and herbs, and required only a bundle of agricultural waste to run. Research published at Tongji University confirmed that a properly designed Kang system reduces total building heating load by between 50 and 80% compared to conventional heating. In 2004, this same technology was still in active use in 67 million homes across northern China, serving 175 million people. 5 centuries later, on the other side of the Sea of Japan, a civilization with zero documented contact with northern China arrived at the same conclusion through different materials and different hands. During the Kofun period in Japan, roughly 252–538 CE, craftsmen developed the kamado, an earthenware clay vessel with a combustion chamber at the base and cooking holes at the top. The kamado cooked and heated simultaneously, using enclosed combustion to capture heat that open fires wasted in every direction. It steamed, it boiled, it grilled, it fried. It used a fraction of the fuel an open fire required. Simultaneously, on the Korean peninsula, builders were constructing the ondola system of underfloor flues that channeled heat from a single fire beneath an entire room's floor. The Korean Ondol, the Chinese Kang, and the Roman Hypocaust were 3 civilizations, separated by oceans and centuries, arriving at the same principle independently: enclose the combustion, route the heat through mass, and release it slowly. That is not coincidence. That is thermodynamics. In 2008, researcher Zhong Li and colleagues published a peer-reviewed analysis in ScienceDirect examining the thermal performance of the Chinese Kang system. The paper later expanded by Tongji University researchers in a 2020 study published in the Journal of the Architectural Institute of Japan documented the mechanism at the level of heat transfer physics. The Kang works because clay and brick have high thermal inertia. They absorb heat slowly and release it even more slowly. Hot combustion gases generated by even minimal biomass fuel, straw, corn stalks, agricultural waste travel through internal flues beneath the clay surface. The contact time between hot gas and thermal mass is long, the heat transfers into the mass. When the fire stops, the mass does not stop. It continues radiating warmth into the room for hours. According to the documented research, a well-designed Kang can reduce building heating load by 50 to 80% compared to conventional space heating systems. This is not a claim by an enthusiast. This is a peer-reviewed, institutionally documented thermodynamic measurement. The modern DIY aluminum can stove extends this same principle into a portable format. Denatured alcohol ethanol rendered undrinkable by additives burns at the molecular level in a clean, documented chemical reaction. Ethanol plus oxygen produces carbon dioxide, water, and heat. The aluminum body acts as a pressure vessel. As the alcohol heats, it vaporizes and builds pressure inside the sealed cavity between the inner and outer walls. The pressurized vapor forces itself out through small jet holes punched around the burner rim, creating a focused, directed flame rather than an open pool burn. 1 fluid ounce of denatured alcohol burns for 10 to 12 minutes. Half a fluid ounce, approximately 15 milliliters, is documented by multiple field testers to bring 500 milliliters of water to a full boil. A gallon of denatured alcohol costs under $20 at any hardware store. Most people walk past this solution every single day without any idea what it can do. The ones who find out tend to make sure the people they care about find out too. So why has no survival manual ever listed this stove by name as your primary emergency cooking system? Here is what a $600 million industry looks like. Coleman, Jetboil, Miser Mountain Safety Research, Camp Chef, Primus, Solo Stove. These companies sell you a stove. Then they sell you canisters of pressurized butane or propane to feed that stove. Then they sell you replacement canisters. Then more replacement canisters. The canister is proprietary. The valve is proprietary. When the canister runs out, you go back to the store. That is the model. That is the entire architecture of the business. You cannot patent denatured alcohol. You cannot trademark a soda can. You cannot build a subscription around a process that costs $1 to replicate with materials from any recycling bin. You cannot charge recurring fees for a fuel that every hardware store, gas station, and pharmacy carries for under $10. The financial logic here requires no conspiracy and no board meeting. It only requires that the industry has no incentive to promote a solution that eliminates the customer relationship entirely. Every dollar you spend on denatured alcohol goes to a hardware store's shelf, not a proprietary outdoor brand. Every stove you build from 2 empty cans is a sale that never happens. Regulatory frameworks around outdoor fire safety focus almost entirely on pressurized canister systems because that is where the money and the lobbying exist. The DIY alcohol stove sits outside that entire framework. No certification needed, no branded fuel, no recurring purchase. The industry does not suppress this technology by sending anyone to remove it from the internet. It suppresses it the quieter way by simply never mentioning it, never funding it, never teaching it. That is not oversight, that is architecture, deliberate and sustained. Now here is exactly what to do with the DIY alcohol can stove. You need to empty 12-ounce aluminum cans soda, beer, it does not matter, and a bottle of denatured alcohol. Find denatured alcohol at Lowe's, Home Depot, or any hardware store for approximately $7 per quart. You will also need an awl or sturdy thumbtack, pliers, high-heat epoxy under $10 at any hardware store, a square of fiberglass insulation, sandpaper, and a ruler. Total material cost outside the cans, under $15 for supplies that build many stoves. Step 1. Drain, rinse, and dry both cans. Ancient peoples in China built this thermal system 7,000 years ago and never let the fire die. Modern peer-reviewed science at Tongji University documented exactly why it worked. A $600 million canister stove industry built its entire business model around the assumption that you would never find out. Now, you have found out. This knowledge did not disappear. Someone made sure it stayed buried. Drop a comment. What else do you think got buried the same way? If this video opened something for you, subscribe now. The next vault opens soon. What is inside is even heavier than this.